Okay, the next, those went pretty well. The 1, 2, 3, 4 went pretty well. These didn't go so well. Right, these two, you were supposed to find the vertical asymptotes, right? Do you remember, how do you find the vertical asymptotes of a rational function? Set the denominator equal to 0, right? And since this was already in factored form, when you set that equal, it just says what value of x is going to make each one of these factors equal to 0. Now, some of you are good at just inspecting that and saying -3 halves, right? Because that'll divide by 2, will cancel the 2, the -3 plus 3 will cancel. But if you're not, you should be taking that and setting it equal to 0 and solving it like an equation. So x equals -3 halves was one of the asymptotes. And the other one, by inspection, 1, right? 1 minus 1 is 0, x equals 1. Right? This one, if you set it equal to 0, you find that it doesn't have any real zeros. You get an imaginary number. Now, there was a fair number that tried to factor that, like x plus 1 times x plus 1. But remember, we don't have a formula for the sum of squares. We have a formula for the difference of squares, not the sum of squares. Right? Can't be factored. So this one, there were no vertical asymptotes because there was no real numbers that would have made zeros in the denominator. Okay. The next, we were finding horizontal asymptotes on 7 and 8. There we go. And remember, a horizontal asymptote, we had 3 rules for this. That is kind of bright. We had 3 rules for this. Let's try this. A little better. And they were based on what? The rules for horizontal asymptotes were based on, Erica? She got the hard word. Now you need the easy word. The degree of the numerator and the degree of the denominator, right? What do we mean by degree? The highest power term, right? So the numerator was second degree and the denominator was second degree. So what does the rule tell us about the horizontal asymptote? Peter?
They divide the 2 numbers, the coefficients before the variable.
Well, specifically, it's the ratio of the coefficients of the highest degree terms. So because x squared and x squared were the highest degree terms, it was y equals 3 over 9. Right? It didn't matter that they were written at the end. It's still y equals 3 over 9 or y equals 1/3. Okay, what was the rule for when the numerator had a higher degree than the denominator? None, right? None. Because remember, a horizontal asymptote is like an invisible line on the graph that your function is going to approach. It'll be kind of limited by that as x gets really large. But when the numerator has a higher degree, when x gets really large, the numerator grows way beyond the denominator. So the graph is just going to go to infinity. It's not going to approach one fixed value. No horizontal asymptote. How are we doing there? Did we run it down?